Warning: the procedures in this video produce large quantities of toxic gases and deal with highly corrosive acids. All work must be performed in a fume hood with proper safety equipment, and all apparatus must be glassed to withstand the acids. Greetings, fellow nerds. Nitric acid is an extremely useful acid capable of dissolving copper and silver. In this video, we're going to show you 3 approaches to making it. For the first method, we start with about 80 grams of a nitrate salt. We're using sodium nitrate, but you can also use potassium nitrate, ammonium nitrate, or even a nitrate-based fertilizer as long as it passes the nitrate test we showed you in the previous video. Alright, add around 50 milliliters of water to your nitrate and try to dissolve as much of it as you can. Then, carefully add 100 milliliters of hydrochloric acid. Give it a few minutes to settle, and in this larger container, place 50 milliliters of water. Now place the acid mixture inside the larger container like this. Now get at least 32 grams of copper, in excess is better, and pour it into the acid mixture. Now place a container large enough to fit over the inner container, but small enough to fit inside the outer container into the apparatus. And now, just wait. The copper reacts with the nitric acid and nitrate mixture to generate nitrogen dioxide gas that flows out and is forced into the water mixture where it dissolves and produces nitric acid. This process is not very efficient, but it works. We place this weight over the container to keep it from bumping too much. This took about an hour, so we'll skip over that part. Alright, here we are. Take out both inner containers. Pour out the acid. And here is your really weak nitric acid. It's green because it's highly contaminated with the original reaction mixture that splashed out, but it's still somewhat usable. To test it, just pour it over some pieces of copper. Only nitric acid can dissolve copper. Now, to generate cleaner acid, use a more sophisticated gas generator, which simply consists of this vacuum flask with a plastic tube and a glass pipette at the end of it. Do not omit the pipette, since you don't want the acid produced getting on the tube and possibly reacting with it. Now fill the flask with 80 grams of nitrates, just like before. Then add 50 milliliters of water and at least 32 grams of copper. Do not add the hydrochloric acid yet. Our mixture in the video is turning green because we use recycled copper waste from our lab. If you use clean copper, this shouldn't happen. Anyway, get a container that can fit a 25 milliliter graduated cylinder. Then fill the cylinder with 25 milliliters of 30% hydrogen peroxide. The peroxide is optional, but it helps to improve the nitric acid yield. You can use water if you don't have peroxide, but your yield will be lower. Okay, now pack the container with ice and fill it with water to form a slurry. This ice bath for the cylinder helps more of the nitrogen dioxide dissolve and react before it escapes. Now lead the gas generator output pipette into the graduated cylinder. Okay, when you're ready to start, pour 100 milliliters of hydrochloric acid into the gas generator and stopper it off. And there goes the reaction. This took about an hour to finish, so we'll skip ahead. Now simply take apart the apparatus and get your acid. And here it is. Still dilute, but stronger than the other method and very clean. You can test the acid by pouring it over copper. Now we can't predict the concentration of the acids you'll obtain because everyone's setup will be slightly different. But if you want highly concentrated acid, you can distill the acids by fractional distillation to obtain an acid of 70% concentration. You cannot go higher because nitric acid forms an azeotrope with water. But as you can see here, concentrated nitric acid is still extremely reactive. Now for both methods, lots of copper was used, but copper is pretty costly for the amount of acid you get. But you can actually recycle the copper to use again for more acid. Get the dead reaction mixture and simply add aluminum metal. This is going to produce lots of heat and hydrogen gas, so be careful. We use aluminum foil, but this is actually pretty expensive. It's actually cheaper to use aluminum cans that you've sanded off the labels. Okay, keep on adding aluminum metal until no more metal dissolves. Then take out all the extra aluminum bits and filter off the mixture. The solid product is copper. It's highly contaminated with aluminum metal, but it's still very usable to make more nitric acid. Alright, in this final method, we're going to make nearly pure nitric acid. First, get a round bottom flask and fill it with about 50 grams or so of a pure nitrate salt. Do not use impure fertilizers for this. Get your condenser ready for the acid. Now add concentrated sulfuric acid to the nitrate. We used 100 milliliters so you could see it on camera better, but this is far too much. You can use stoichiometric amounts to save on the valuable sulfuric acid. Attach a still head with a glass stopper at the end. You can install a thermometer if you want, but this is optional. Now get a high temperature oil bath ready, and with water in the condenser on, turn on the heat. What's happening is the nitrate salt is reacting with the sulfuric acid to create a sulfate salt and nitric acid, which boils out of the mixture, driving the reaction forward. The brown-yellow color of the gases results from some of the nitric acid decomposing into nitrogen dioxide, oxygen, and water from the heat. The acid on the left is yellow due to nitrogen dioxide contamination, but this is very little. The acid in there is actually stronger and purer than the concentrated acid we showed earlier. Now the whole distillation took an hour, so we'll skip over that part. And here we have our nearly pure nitric acid. It's also called fuming nitric acid for this reason. If you blow air into it, it fumes. Do not inhale. Okay, now something surprising about pure nitric acid is that if you add it to copper, it actually reacts pretty slowly. This is because pure nitric acid is so strong that it actually reacts with copper to form a protective layer that resists further attack. This process is called passivation. But to break this effect, we just add a little water to lower the concentration of the acid. And there it goes. Alright, thanks for watching. Please subscribe, rate, and comment.